This is the first class of my beginning algebra course. Today we're going to talk about three things. We're going to give an introduction, and we're going to talk about how to stay organized, and also the course content. This is the most important class of the course because we're going to talk about how to conduct yourself in the course. This is where you are. Beginning algebra. It's also called Algebra 1. You should be aware of that. It's just a different name. And the purpose of this document is just to show you why math is important. I could probably talk for 2 hours just about this whole idea about why math is important in the academic system, but I don't want this class to go too long, so I'm just going to move on from that. Beginning algebra is typically a ninth grade course, but I want to stress that there is no age requirement. The only requirement is that you finish pre-algebra first. Pre-algebra is the prerequisite for this course. If you don't know what prerequisite means, that's just a course that you have to take before taking this course. And I also want to emphasize that this course is going to be about 3 times more difficult than the previous course, pre-algebra. The algebra in this course is just much more involved. It's much more rigorous. And so you need to psychologically prepare yourself for the difficulty of this course. It's not that I'm trying to make it difficult on purpose. It's just the nature of the material. So I'm not trying to scare you. You're perfectly capable of learning this material, but you just need to understand that this course, as well as any math course, requires a lot of effort. Now, there's no textbook required for this course. I'm going to provide all class problems, all the answers for the class problems, and all the homework problems, and all the answers for the homework problems, and the tests. So you don't need to worry about getting a textbook, but if you want to get one, that's okay. A supplementary textbook may be useful, but again, it's not required. And also, I'm going to talk about what textbooks to get, because you need to be aware that there are some textbooks that are not very good. In fact, most of the textbooks out there that K-12 schools use are not any good. So if you do want to get a textbook, you need to get one that, focuses on what you really need to focus on. So I'm going to talk more about that. The best advice that I can give you when it comes to choosing a math textbook is you want to choose the books that community colleges use for their remedial math courses. Community colleges do teach high school level math because most students that are going to college, they have to take remedial math. I remember when I was taking, vector calculus, there was only maybe 20, 25 students in the class. But when you take a course like beginning algebra at a community college, there's, 100 students, maybe 100, 200 students, because most students are not they're not learning the math that they need to learn in K-12 schools, so they have to retake it in college. And so the community college math textbooks, or the textbooks that the community colleges use for their remedial math courses, are designed to repair the damage that was done in K-12 schools. And I'm going to explain more about that in the course content part of this class. And the big difference between a good textbook and a bad textbook is a good textbook, they focus on algebra. Whereas almost all K-12 textbooks, they don't focus on algebra and they don't really focus on anything. They just dump a bunch of random stuff into the curriculum and students end up mastering none of it. So this is an example of a textbook that community colleges use, and it focuses on algebra. That's why it's better. So if you're going to buy a textbook, you want something like this. And you can get used textbooks for $5. You don't have to get the latest edition. The only reason they keep writing more and more editions is they just want to make more money. It has nothing to do with improving the curriculum whatsoever. So don't be afraid to buy, an early edition. There's no difference. And I'm not going to give an example of a bad textbook because almost all K-12 math textbooks are not any good. So any textbook that's designed for K-12 schools is probably not going to be good. So this is, the general guidelines that I would give you if you're going to look for a math textbook. As far as the pace of the course, you need to watch 2 videos per week, and each video has a homework assignment. So you're going to be doing 2 videos per week and 2 homework assignments per week. That's the minimum that you need to make progress and to actually learn the material in this course. If you go any slower than that, then you're just not going to get enough to really make sufficient progress. And if you do 2 videos per week and 2 homework assignments per week, it'll take about 4 months for this course, for you to get through the course. Now, I just want you to be aware that you can do more. You can do 3 or 4 classes per week, and theoretically, you could even do 5 or 6 classes per week if you really want to do, or even maybe more. But I just want you to be aware that if you do more than 2 videos and 2 homework assignments per week, it's going to start to get to the point where you're going to feel like all you're doing all day long is math. And for most people, that's going to be very difficult. Now, if you have some unusual fascination with mathematics, and you want to, if you feel okay doing 3 or 4 classes per week and 3 or 4 homework assignments per week, then go ahead. But most normal people, they're not going to want to do that. So I really don't recommend for most people to do more than 2 classes and 2 homework assignments per week. Also, you need to be aware, a lot of people think that you can just, watch 10 videos per week and just watch the video and you don't really have to do the homework assignment. But you need to understand that the limiting factor in your moving through this course, the speed that you can move through this course, the limiting factor is the homework. As I'm going to explain, it's not enough just to watch the videos. The purpose of this course is to learn fluency in algebra. What I mean by that is you need to know how to read and write algebra. And, so algebra is kind of like learning a foreign language. But it's more difficult than most foreign language courses. Like, for example, I learned Spanish when I was in college. Some people learn, German, whatever. If you take a foreign language course, the first, 2, 3, 4 courses, you're not required to learn fluency in that language. You learn some nouns, you learn some adjectives, prepositions, so on and so forth, but you're not required to know fluency. In mathematics, you are required to know fluency, and that's why math is so much more difficult than most foreign language courses. And the only way to gain fluency is to do homework. When you do the homework, that's when the real learning begins, because when you're just watching somebody else do math, you're not using 100% of your mind to learn the material. But when you're doing homework, 100% of your attention is on that homework, and that's where the real learning begins. That's where the real fluency, learning fluency in the math actually occurs. So if you don't do the homework, and I'm going to tell you 100 times over again in this course, if you don't do the homework, it's a 100% guarantee you're going to learn absolutely nothing that you're supposed to learn in this course. Because again, the entire course is learning fluency. If you don't do the homework, you'll learn no fluency whatsoever, and so the objective of the course will not be achieved. So you can't. That's the limiting factor. You can't just watch 10 videos, because that would mean you're doing 10 homework assignments. The homework is what's going to take the most amount of time, and it's the most amount of energy in this course. And as I show down here, 75% of the work in this course is homework. And only maybe about 20% of the work is actually watching my videos. Watching a video is not really that hard. So just be aware of that. Now, if you do 3 to 4 classes per week, you'll get the course done in about 8 to 11 weeks, or 2 or 3 months. The purpose of this document is to show you how fast you can move if you're not in the school system. If you're in the school system, it takes if you count kindergarten, it takes about 15 years to finish the math sequence, and the dropout rate is about 99%. But if you're going through, say, the community college system, and you start at arithmetic, because community colleges do provide remedial math courses, and you go all the way to, all the way through the entire math sequence, then it only takes about 5 years. And so that's a third of the amount of time. And the big question is, why can you move so much more quickly in your local community college? And the answer is they just don't waste time. They don't waste time in college as much as they do in K-12 schools. And they're just more productive and more efficient. In my school, you can move even quicker, and that's the whole purpose of this document. Again, I could talk about this for 2 hours, but I don't want this to go too long. Now, again, in school, it might take 9 months to finish a typical beginning algebra course. In my course, it'll take 4 months. So does that mean that there's something wrong with my course, or does that mean that there's something wrong with school? Well, the basic idea is that in school, about 95% of the time that you spend there is wasted. Only about 5% of the time that you spend in school is actually, preparing for college, doing things that it's actually going to help you prepare for college. This is a college prep school. And the other 95% is just doing, busy work. And this is stuff where, for example, you might decorate a poster or you might do a science project. Now, some people might say, well, wait a second, don't science projects prepare you for college? Not really. I mean, what you do with science projects has very little to do with the science curriculum. So, I mean, it's just there are thousands of examples where you're just doing busy work. The assignments don't do anything to prepare you for college. That's this 95%. In my school, what I'm going to do is I'm going to eliminate that 95%, and I'm going to take the 5%, and I'm going to double it or triple it. So you're going to learn double or triple or maybe even quadruple the amount of information that students will learn in the school system. And so you're going to be learning more college prep information, but at the same time, you're going to be doing a lot less work because I'm going to be cutting out all this busy work and all that, mind-numbing, stuff where you're just staring at a wall or something, and so on and so forth. So that's the whole point of this school, or one of the purposes is to maximize productivity and efficiency. But again, I could talk about that for hours, so I don't want to. I'm just going to move on here. So, how to conduct yourself in this course? About 5% of the work is just studying for tests. You do need to watch the videos, but you don't really need to watch them if you don't want to. What you can do is just go to the end of the video and you can look at my notes. And if you understand how to do the homework, then just do the homework. And if there's something you don't understand about the homework, then you can go to my video and watch and figure out how to do the work. I do recommend that you watch the videos though, because I do explain how to do the problems. But that's only about 20% of the work. Like I mentioned previously, most of the work is doing the homework. And so you do need to, I do recommend watching the videos. You must do the homework. That's most of the work. And also you must study for tests. If you don't study for the tests and you take the tests and you just fail them, then that means that all the work that I put into the tests is for nothing. And, the objective of this course is to prove that you know something, to prove that you learned something. If you take the test and fail it, all that proves is the exact opposite, that you don't know the material. So you do need to study for these tests. And the tests are 600 points and the homework is 400 points. And you might be thinking, wait a second, why are you giving points? This is not a real course. Well, the whole point of, a grade, and again, you're going to give yourself a grade in this course. The whole point of points and calculating a grade is to let you know whether or not you've learned the material. I mean, that's the point of a grade. If math is something that you have to perform. You have to actually be able to do it. If you can't do the math, then you don't know it. This is something where you actually have to take tests and you have to perform and you have to demonstrate that you can perform. And so this is going to tell you whether or not you learned enough in this course to actually say that you have completed a beginning algebra course. So this is extremely valuable to score your tests and score your homework and so on and so forth, and to give yourself a grade. All right, so and I just want to say again, because a lot of students, they will say, well, I'm just not going to do the homework because that seems pretty tedious. But I want you to understand very clearly that no one in the history of mankind has ever passed a math course without doing the required homework, unless you cheat. But if you cheat, that's not really passing a math course. That's just cheating. You know, it's not possible to learn the material in any math course without doing the required homework, period. No one has ever done it, and you will not do it. So the homework is mandatory. And also, I provide the answers for the homework. Now, a lot of people will say, wait a second, if you're providing the answers, then that means that students can just, well, first of all, people want to know, why are you providing the answers? Well, I'm providing the answers so students can make sure that they did the problem correctly. I mean, I don't mean to be rude, but isn't that kind of a stupid question? I mean, the whole point of the homework is to make sure that you're learning the material. If you don't have the answers, how do you know that you did it correctly? Now, a lot of people will say, well, won't students just write the answers? Well, no. I mean, they could write the answers, but all that proves is that they didn't do the work. What's going to prove that you did the work is that you can show all the steps required to get the answer. Math requires steps. You have to show the work that you did to get to the answer. That's going to prove that you know how to get the answers. So don't think that students can just write the answers. That doesn't prove anything other than they just didn't do the work. Now, as far as my classes, 95% of the classes will be practice problems. That's all I'm going to be doing is really just practice problems. And half of those problems you will be expected to do on your own. So I'm going to do a couple practice problems, and I'm going to say, okay, now it's your turn, and you're going to do those problems, and you're going to be expected to do them. Don't just watch me do them. And after you're done with the problems, I will do them, and then you can, if you have any questions, you can watch me do those problems, and more importantly, you can make sure that you got the right answer. That's the way the classes work. All we're going to be doing pretty much is just practice problems. And so when you do the homework, you're not going to have any excuse. You're not going to be able to say, well, I don't know how to do the homework. Well, if you don't know how to do the homework, that just means you didn't watch the class. You didn't watch the video. So, don't tell me you don't know how to do the homework. The homework is pretty much almost the exact type of problems that we did in class. Now, if you find that my classes are boring, that's okay. Just, jump forward. You can use the right and left arrow keys to jump 5 seconds forward to 5 seconds reverse. If you think you understand, then just jump forward. Don't complain that my courses are long and tedious. Just jump forward. Use the L and J keys to jump 10 seconds forward or reverse. And you need to know how to take a screenshot. It's going to be very useful to take screenshots. Some people don't even know that anything about screenshots, but pretty much all computers you can do screenshots, and that means you can take a picture of your screen. And this is just some instructions for various computers, but you really need to go online and just type in the model of your computer and screenshot, and it'll tell you how to take a screenshot. So I don't really need to go over that, but it's usually you push the Windows button and then you push the part screen and for a PC, or something like Command Shift and number 3 for Apple. But again, it's different for every model. So you're going to keep all your completed homework assignments and tests in a 3-ring binder or in a digital notebook. So that's what we're going to get to next. That was the introduction to the course. Now we're going to talk about how to stay organized. It's very important that you understand that everything that you do in this course, you're going to put in a 3-ring binder, and you're going to keep a record of all your work. And it's very important that you learn how to keep your work in chronological order. It's not enough just to throw your work in your room or your closet and just scatter the papers all around, or put your papers in a folder. None of that stuff works. You need to keep your papers in chronological order. And you're going to, again, it's just homework and pretty much tests. That's pretty much all you need to keep in your binder. It's simple. Just keep your homework and your tests in chronological order, and that's it. It's really not complicated. But most students, they don't do this. They don't know how to do this. But I want to tell you that if you don't stay organized in math courses or any courses in college or in high school or middle school or elementary school, if you don't keep your papers in order, you should just quit. You should just drop out of school because there's no point in being there. If you can't even stay organized, I mean, staying organized is 50% of the battle when you're in school. It's the foundation of everything. If you can't stay organized, then don't take this course. If you can't keep your orders in your papers in chronological order, just don't take this course. Don't go to school at all. There's no point. You need to stay organized. Now, there are two ways that you can stay organized: a digital notebook and a 3-ring binder. A digital notebook costs about $1,000. All the equipment that you need. A 3-ring binder costs about $20 or $30. So there's a big price difference, obviously. Now, I used to kind of rest towards this because students love using digital notebooks, but now I'm kind of leaning towards this way because, there's problems with the cloud and whatnot, and I'm not quite sold on digital notebook at this point. But so if you're let's talk about the 3-ring binder, and then we'll talk about a digital notebook. I'm just going to give you a few things if you don't know about digital notebooks. There's been a lot of advancements when it comes to keeping your notes, or just note programs in general, and digital pens and so on and so forth. It's kind of exciting, so I'll talk about that later. But let's talk about the 3-ring binder route. If you get a 3-ring binder, and again, a lot of people, they have this attitude like, I don't need you to tell me how to stay organized. But I've worked with so many students. I have over 10,000 hours of working with students one-on-one in math and various subjects, chemistry, biology, physics, so on and so forth. And it's obvious to me that students don't know how to stay organized. They have their own methods. Their attitudes are usually, I know how to stay organized. I don't need you to tell me how to stay organized. But then you look at how they stay organized, and it's not correct. There are ways that you can optimize an organization, and you need to get students off on the right foot from day one. They must. You have to get them. You have to make sure that they know how to stay organized, or else things just fall apart real quickly. So again, this is almost more important than anything else: staying organized. And so what you need to do is you need to get a 1-inch 3-ring binder. It can be 1-inch or 2-inch. I don't really recommend getting a bigger one because the bigger the binder is, the more likely it's going to break apart if you drop it. But it has to be a 3-ring binder. Now, a lot of people are going to say, well, I'm not going to use a 3-ring binder. I'm going to use a spiral binder, or I'm going to use folders. Do not use these things. Do not use a spiral notebook. Do not use folders. And there are a couple reasons for that. Number one, spiral notebooks, if you're given handouts in school, if you're going to print something out that I give you, you can't put it in here. See, you have to keep all of your papers in order, not just some papers. You're not going to keep some papers here, some papers there. No. You're going to keep all of your papers in the same place, and they're all going to be in chronological order, period. Okay, no discussion on that. That's not a recommendation. That's a requirement for my courses, and that's the way you should do it from now on for every one of your courses. The problem with a folder is you put it in there, and number one, it's usually not kept in chronological order. And even if it is kept in chronological order, guess what happens? Students drop these, and the papers fall out, and now your papers are not in chronological order. Don't ever use these for any reason when it comes to these courses or any courses. They're just not a good way to stay organized. So you need to get a 3-ring binder. Also, make sure that the 3-ring binder has diagonal rings. If you use circular rings, what happens is the paper gets damaged, and also it doesn't maximize the amount of paper you can put in a 3-ring binder. You see how these rings are diagonal? You see how they kind of go off to, let me get a color here. See how they kind of go off to the side like that? That's a superior design. If you're going to get equipment, get the right equipment. I mean, why start off on the wrong foot? Just get the correct equipment. These fit a lot of paper, much more paper than the circular rings, And also, these binders don't damage your papers. If you look at papers in circular rings, the papers will get like bent. It's kind of hard to explain, but the papers get damaged. But that doesn't happen with these binders. So you want to get one that has diagonal rings. Again, a lot of people are saying, "Well, I don't need you to tell me this." You do need me to tell you this. You have to get students off on the right foot. Why use equipment that is not optimized for organization and so on and so forth? Lined paper, college ruled. I mean, that's not that hard to figure out. Just get lined paper, and get mechanical pencils, Papermate pencils. The reason I recommend these pencils, first of all, you shouldn't be using regular pencils anymore. I don't know why anybody uses regular pencils. The problem is you use the pencil, it wears down, and then now you have to get a sharpener. Well, why would you do that? Why not get mechanical pencils? Because then when the lead runs down, you just rotate this part down here, and you got more lead. I mean, I don't get it. Why are people still using normal pencils? Just use mechanical pencils. Now, I prefer that you get these and not these over here, because if you get these, when the eraser runs down, you can put one of these erasers on it. With these, you can't put another eraser on it because it actually will it makes it to where the pencil doesn't function properly. These are the type where you have to push the top of the pencil down to make the lead come out. But with these, you just turn this part and it makes the lead come out. So again, we're just optimizing. We're teaching. If you're a student listening to this, I'm teaching you how to use the best equipment. You want to make your school experience, these classes, you want to make your experience as easy as possible. And if you get the wrong equipment, it's just going to make things difficult. Why make things, I mean, school is really difficult for students to get through. Why make it more difficult by buying equipment that is not optimized for your organization? So, extra erasers. Now, you need to get a portable 3-hole puncher, and I don't know if you may use that a lot in this class. You may not use it at all, but it's something that you need to get. And the purpose for that is if you do have to print something out that I give you, and you want to put that printout in your binder, you need to put holes in it. You need to put holes in the paper. And that's what this is for. But you can take this with you. If you take a course in school, you're going to have your binder, you're going to have your pencils and your erasers, and you're going to have this thing. This thing can actually fit inside your binder. So it's right there with your binder. The problem is students typically lose these. And but if these you can actually put in your binder, so it's impossible to lose it. So when you get a handout, you just grab this thing and put the holes in the paper and put it inside your binder, and there you go. Again, this stuff is all just optimizing the chances that you're going to stay organized. Now, if the holes in your paper get damaged, your paper might fly out. So that's the purpose of these, to repair your paper if it gets damaged. And now, when it comes to the 3-hole puncher, do not get the transparent plastic ones, because those, all you have to do is drop those one time and it'll break. Every time students buy these, it's 100% guarantee they're going to drop it, and it's 100% guarantee they're going to break. Don't get that transparent plastic type because it's just really cheap. Get this type. It's not that expensive. It's $5.29 at wherever that was. I can't remember where that was, but every place that sells school stuff sells those pretty much. And so let's look at the binder now. I'm going to talk about how I want you to keep your binder organized. It's really very simple. I don't really need to talk about this that much. So this is going to show this is a 1/2-inch binder, so you need to get a 1-inch binder, so be aware of that. You're going to put your paper, the first paper for the class, and then the second paper for the class, and the third homework assignment and fourth homework assignment. You need to keep it in order. So the earliest homework assignments are going to go at the front, and you're going to, if you have to, print a handout. I don't know if I really require you to print handouts, but if you do, you're going to put the paper in this 3-hole puncher and put holes in it, and then you can put that in your binder. The most important thing is that everything needs to be together in your binder. You want to keep everything in one place. If students keep things in different places, then it's just it greatly increases the chances that they're going to lose things. Now, notice that there's this sleeve on the left, at the bottom left. A lot of times students like to put papers in that sleeve. Never, never, never put papers in that sleeve. And the reason you don't want to put papers in the sleeve is because they're just going to fall out. You want to keep everything in chronological order in that binder, and you can keep, like I said, you can keep your 3-hole puncher in the binder. So it's not going to get lost. And if you have a folder or a binder, that is 1 inch or greater, then the 3-hole punch is going to be able to fit in there really well. But if you get a 1/2 inch like you see here, it's not going to fit very well. It's not going to close all the way. So you want to get a 1 inch or greater. All right, so that was how to stay organized with a 3-ring binder. Again, a lot of people are going to have this attitude that I don't need your advice about how to stay organized. This is a requirement for my classes. This is not a recommendation. You need to get all these things. It's required. I don't want you to use your methods. I don't want you to come up with your, try your methods or somebody else's methods, or this thing looks. I want to try this particular spiral notebook or whatever. Don't do any of that. I want you to use this stuff in my courses because this is the best way to stay organized. Now, I'm going to talk about digital notebooks a little bit. The good thing about a binder is that it's a hard copy of your work. And, a hard copy is, it's a hard copy. It's, this is just digital. And so there's a chance that your work could get lost. But at the same time, there's a chance that your work could get lost here too. But obviously, this is the cheaper way to go, and it's a hard copy. But with a digital notebook, obviously the downside is it's going to cost at least $1,000. And the other downside is there's a chance that maybe you could lose your work. But actually, you could make an argument that it's less likely that you could lose your work, because when you use these products that I'm going to tell you about, and I'm not a spokesman for Microsoft or Apple, but I'm just telling you what's out there, and I have these products myself, so I can tell you how they work. When you use these products, you're going to be able to keep your data on the cloud. Now, a lot of people say, "Well, I don't know if I want to keep my data on the cloud." Well, the cloud is really effective because if you let's say that you have a computer or a tablet and you drop it and smash it, well, that's okay because your data is now on the cloud. So it's in that way it's less likely that you're going to lose your work. Also, students just like using digital notebooks way more than they like using a pen and pencil with a 3-ring binder. So that's one thing that might motivate kids motivate kids to actually do their work, is they get to use these products. But I want to say that I'm not telling you that you have to get a digital notebook. It's not necessary. It's just something that may help students. And by the way, I'm using OneNote. If you're gonna, there's 2 routes you can go. You can get you can use a PC or you can use the iPad. Those are the 2 products that I know of. But regardless of whatever you use, what I'm using is OneNote. That's probably the most common note-taking program, and I'm using OneNote right now. So if you see over here, I've got a notebook. I've got dividers. Look on the upper left up here. I've got arithmetic, pre-algebra, beginning algebra, geometry. These are dividers. See the colors, the yellow, blue, red, green. Those are like dividers. And in between the dividers, there are pages. See all these pages for beginning algebra? I'm on beginning algebra right now, but I can change to geometry section, and I've got all my geometry classes. So this helps students to stay organized. And so that's one benefit of a digital notebook. Not that it's really that difficult to stay organized with a binder, but it's just it helps students. And if you don't know, OneNote is part of Microsoft Office. Everybody knows about PowerPoint, everybody knows about Excel, and everybody knows about Word. But actually, relatively few people know about OneNote. OneNote is part of Microsoft Office. It's basically a note-taking program. And that's what you're seeing right in front of you. You can use a digital pen to take notes, or you can actually type. You can actually click and see that icon right there. I can actually type inside OneNote. So it's a really useful program, and for the most part, it runs pretty well. And so that's the software that I would recommend. Now, there are other note-taking programs, but I've never used them, so I can't recommend them, but OneNote is pretty good. And also you can put pictures in OneNote, see all these pictures and so on and so forth. Now, there are two ways to go. There's a 2-in-1 laptop. If you don't know what 2-in-1 laptops are, there's a huge market for 2-in-1 laptops right now. And this is especially useful for students in school. Most students don't use 2-in-1 laptops. And the school system could probably afford to buy students tablets and 2-in-1 laptops, but it just hasn't really happened yet. But a 2-in-1 laptop, if you don't know, it's a laptop that flips over completely 360 degrees, so it becomes a tablet. If you buy a 2-in-1 PC laptop, then you have to get one with Windows Ink. That means it's compatible with a digital pen. It's designed to be compatible with a digital pen. If you don't get one that's compatible, that has Windows Ink, it's not going to work with a digital pen, so just be aware of that. The bamboo pen is the most common pen used. That's what I'm using right now. And so that's the PC route. Now, you can also go the iPad Pro route. And you actually don't need the iPad Pro. The iPads that they have now, it used to be that only the iPad Pro would work with the digital pen, but now I think pretty much every iPad that they're selling works with a digital pen. So they're becoming more affordable. Now, there's no question that the Apple Pencil, there's no question that the Apple Pencil is the best digital pen in the world. It works so good that students, a lot of the students that I work with, they look forward to working with me just because they want to use my iPad. What I do is I have this computer at home and I use the iPad on the go. That's just the way I decided to do it. But you don't really need both. And so the iPad, it's becoming more affordable. It used to be that you'd have to pay at least like $800 for an iPad. But now they're coming out with smaller ones. You don't really need a big one. They're coming out with smaller ones that are like $400 or $500. So it's becoming more affordable. It's not exactly cheap, but that's another way to go. And also be aware. People know that you can use Microsoft products with a PC. In other words, you can use OneNote with a PC, but just be aware, you can now use Microsoft software with Apple products. And so you can use OneNote on your iPad, and that's what I do on the go. And the cloud, again, the cloud helps you. It helps to protect your data. If you have a tablet and a 2-in-1 laptop and a smartphone, all those devices sync to the cloud. So if you make a change in one of these devices in your OneNote program, it'll sync to the cloud, and then it'll change that document in all these other devices. Now, I'd like to say that it works perfectly, but unfortunately, the Microsoft Cloud does not work perfectly, and there are problems, but still, it works fairly well to protect your data. So that's another benefit of the digital notebook. So that's what I had to say about staying organized. And again, some people may say, well, I don't need you to tell me all this, but you do. These are the most important things when it comes to, staying organized. So you don't have to do both of these. You can just choose this or this. And there are benefits and negatives to each method. But that's how to stay organized. And again, whatever method you choose, you need to follow. These are requirements for the course. They're not suggestions. All right, so now we're going to talk about the course content. And, I could talk for hours about this. I'm going to try to keep this short. If you're a student who trusts that I know what I'm doing, or a parent who trusts that I know what I'm doing, you don't really have to listen to this. This is only for people who, are concerned and they want to know, how do I know what to teach in beginning algebra? First of all, the math curriculum is not top secret information. It's something that, just buy a book and look at it. It's not something that is really that difficult to figure out. But there is a big problem that I want to discuss regarding the content. First of all, this is ninth grade mathematics. Like I said, the first year of high school mathematics. And as far as pre-algebra review, I'm not going to go over any pre-algebra really. And if you want to review pre-algebra, then you can go back to my pre-algebra course. One of the problems with the courses in schools is that sometimes 50% of the course is just reviewing the previous course. And that's, incredibly inefficient, and it's just a huge waste of time. And there's just no reason for me to do that because, again, if you need review in pre-algebra, you can just go back to my pre-algebra course. Now, to start off talking about the course content, if you're going to determine the course content, whether or not a curriculum is good or bad, the first thing that you need to ask is, what is the purpose of the course? Most people, even most K-12 math teachers, they don't know what the purpose of algebra is. They don't know why kids are even supposed to be learning it. If you ask them, they can't really give you, a good answer. And so for that reason, most people, they don't know what is supposed to be taught in an algebra course. And unfortunately, you're not going to want to hear this, but it's the truth, so I'm going to tell you, there is no easy way to ensure quality when it comes to the academic world. The only way to really know is to have experience in the academic system, and when it comes to math, experience means that you're a STEM major. If you don't know what STEM means, that's an acronym that means science, technology, engineering, and mathematics. STEM majors, they understand what is required to go on to upper mathematics. STEM majors have taken calculus. They've taken hardcore biology courses, hardcore chemistry, hardcore physics, and they understand what you need to do in algebra to prepare for upper math courses. But here's the big shocker. Most K-12 math teachers have never taken calculus. They've never taken hardcore biology, physics, chemistry, so on and so forth. And so they don't really even know, why kids are taking algebra. They don't know what the point of it is. And so let me tell you what the point of algebra is. And you could give varying explanations for what the purpose of algebra is in middle school and high school, but the best explanation, the best answer is what I'm about to give you now. The reason that kids are forced to learn algebra in middle school and high school is to prepare for the possibility that they might want to get a STEM degree. Again, science, technology, engineering, or mathematics. If they want to be engineers, if they want to be mathematicians or scientists, they have to take calculus. The problem with calculus, and by the way, if you want to be a hard science major, like an astronomy major or an engineer or a geologist or biology, physics, chemistry, the real, not biology, but the hard courses, you have to take 4 semesters of calculus. If you want to be a biology major, life science major, generally you have to take 2 semesters of calculus. And if you want to earn an economics degree, you have to take 2 semesters of calculus, usually. These are general rules. It may be slightly different from college to college, but almost all colleges have the same basic requirements. The problem with calculus is that if you're not fluent in algebra, you won't make it past the first day in a calculus course. In fact, if you're not fluent in algebra, they won't even let you take the course. You have to fulfill these prerequisites before you take calculus. You have to take an arithmetic course, and then you have to take a pre-algebra course, and then a beginning algebra course, and then a geometry course. Actually, technically, geometry is not really required to go up into upper math, but many colleges are requiring that course to be completed now. And you have to take an intermediate algebra course, a trigonometry course, and a pre-calculus course before you can take calculus. They won't even let you in the door unless you've learned all this material highlighted in yellow. Because again, they know that you're not going to make it past the first day of calculus unless you have those prerequisites fulfilled. So that's the purpose of taking algebra in middle school and or forcing students to take algebra in middle school and high school. It's to prepare you for the possibility that you might want to choose a STEM degree. Because if you get into this mindset where you say, well, I'm not going to, I don't want to be a scientist or a mathematician or an engineer, so I'm not going to take any algebra. But then you later on change your mind and you decide, well, I think I will do one of those things. You can't. You won't have the option because you don't have the algebra. It takes so long to learn fluency in algebra. Algebra is not the type of thing that you can learn in a couple weeks or even a couple months. It takes years to learn algebra, to learn fluency in algebra. So that's the purpose of this course, is to prepare you for calculus, prepare you for the possibility that you might want to take calculus. The problem is like I said, most K-12 math teachers have never taken calculus. So most K-12 math teachers are teaching courses that are designed to prepare students for courses that the teachers themselves have never taken. And so what ends up happening is, teachers don't focus on the things that they're supposed to focus on. This is what teachers are supposed to focus on in a typical beginning algebra course, and this is my curriculum. This curriculum focuses on fluency in algebra. Now, in high school, students are required to take 2 years of algebra. Actually, they're required to take 3 years of math. Some high schools don't necessarily follow this because they don't really care if you're prepared for college. But that's the absolute minimum that high schools are supposed to require is 3 years of math, 2 years of algebra, and 1 year of geometry. Now, that means that 2/3 of the math that you do in high school, are you listening? 2/3 of the math you do in high school is algebra. And those courses are entitled Beginning Algebra, that's 9th grade, and 11th grade is Intermediate Algebra. The title of the courses are algebra. That's the point of it. And so that's the point of this course, and as well as intermediate algebra, is to learn algebra. It's to learn fluency in algebra, to learn how to read and write algebra, to know what you're looking at when you see algebraic symbols, the syntax, the operations, the language, the symbols. That's the point of this course. And the reason that you need to know that, again, is when you take calculus. I don't mean to sound like a broken record, but I want you to make sure you understand this. When you take calculus, you have to know those things, or else you can't get past the first day of calculus. Now, a lot of people a lot of people focus on other things. They try to convince people that other things beyond this are really important. And there are a lot of things that you need to learn beyond this material that are important, and I am going to teach those things in other courses. But this is more important than anything else. This is the priority. Because it doesn't matter what else you know. And this is the most important thing that so many people who don't have STEM degrees don't understand. And that is, if you don't have this information down, it doesn't matter what else you know. If you don't know fluency in this information, you're not going to be able to take a calculus course. You're not going to be able to earn a STEM degree, and you're going to be in your entire education when it comes to earning a STEM degree in college is going to be sabotaged. And that's what's happening to students in the school system, is they're not learning fluency in these topics, and so they're handicapped. Now you might be saying, well, this doesn't look like a very big list, but understand that it'll take the entire duration of the course just to learn this information. You know, it takes the entire duration of any beginning algebra course just to learn this information, to learn fluency in this stuff. Now, if you look at a typical beginning algebra book that is used in K-12 schools, you might see a very, very different curriculum than what you see here. And I want to explain to you why my curriculum might be very different from a curriculum that you'll see in a typical K-12 math textbook. What I'm going to tell you right now is kind of what is going on with the K-12 curriculum, just so you can understand. And again, I want to say, like I mentioned, there's no easy way to ensure quality. The only way for you to ensure quality is to know something about the curriculum. If you don't want to know something about the curriculum, then you're just rolling the dice. Now, if you have a STEM degree, you have an idea of what kids are supposed to know. So when you look at this stuff, you're going to know that these are really important concepts, and this is really the core material that students need to know in order to go on to advanced math courses. But if you're a liberal arts major, you're going to be lost. Again, I'd like to tell you that there's an easy way to ensure quality, but you know, the schools, they don't ensure quality. I mean, nobody out there is really ensuring quality. You know, for example, all public schools are accredited, but are all public schools good? No. I mean, I would say that almost all public schools are pretty much crap when it comes to academic quality. Now, if you look at the teachers in the public school system, they're all certified. Are they all good? No. So certification is not an assurance of quality. If you look at the schools, at the accreditation, you know, there are some schools where it's not physically safe for students to even attend. They can get raped, murdered, beaten, you know, but they're accredited. A school that's not physically safe to attend is oftentimes credited. So accreditation is not an assurance of quality. So again, there is no easy way to ensure quality other than to just know something about the curriculum. But I am going to try to guide you through this and kind of tell you, I'm about to tell you what the situation is when it comes to math in the United States. And I'm going to give you some quotes. I don't know if we have time to go over this stuff, but I'm going to give you some quotes and some resources, because I want you to understand it's not just me who understands these things. A lot of people have come to these conclusions. But here's what's happening in the United States when it comes to the math curriculum. And this is just a theory. You know, I don't know exactly why things have evolved this way. But apparently, you know, in the 80s and even in the 90s, a lot of people were recognizing that kids really weren't learning much in school when it came to mathematics. They weren't learning enough to actually prepare them for college. And so what happened was a lot of people like me were telling the school system, hey, you're not teaching enough math. And what they meant by that, and that's coming from STEM majors, what they meant by that is students are not fluent in algebra. They're not learning enough algebra to prepare for college. But the teachers in the K-12 schools, they misinterpreted that. And again, this is just a theory, but they misinterpreted that. And they just thought, well, what they're saying is, let's just take a bunch of concepts, random concepts, and dump them into the courses, the algebra curricula. So here's a perfect example. This is the beginning algebra curriculum. This is what students are supposed to learn. But what happens with textbooks and with you know, typical curricula is they take a bunch of random things that really don't belong in beginning algebra, and they just kind of dump it into beginning algebra to try to satisfy people, to say, look, we're teaching more math, we're teaching a lot of math. The problem with that, the number one problem with that is, and by the way, all these topics here are very important topics. You're going to learn all these topics pretty much. You're just not going to learn them in this course. I'm going to teach these things in other courses. You have to understand that if you look at any beginning algebra course or compare any two beginning algebra courses, they teach different things. Two courses are considered equivalent if 75% of the material is the same. But oftentimes when you compare two beginning algebra courses in the same school, the curriculum will be vastly different to the point where 50% of the curriculum is different, and it's the same school, it's just different teachers. So there's a huge variation in terms of what teachers choose to teach, and there's no real standards that teachers go by. As long as I'm talking about standards, I might as well give you a resource here. I'm going to show you something that you can use to compare my curriculum. I'm going to show you the Massachusetts state standards for beginning algebra. I don't really care about the Massachusetts state standards or any state standards because nobody follows them, and the people that write them don't really know what to focus on in order to prepare kids for college. So I don't really care myself. But I'm just showing you this. You can look at this as a something to compare my curriculum with. So this just ranks the states in terms of the student performance, I guess. Massachusetts is at the top, and California, the state that I'm from, that's near the bottom, as you can see. So I'm not going to look at the California state standards because that's probably not going to inspire confidence in you. But I'm going to look at Massachusetts. So if you look at the Massachusetts, you can just go on this web page and you can see the link there. It's Massachusetts Department of Elementary and Secondary Education, and if you go down to the bottom here, it says mathematics. And you don't really have to do this. I'm just showing you, if the best thing that you can do as a student is take control of your education. This is not stuff that is that difficult to figure out. If you start to take control of your education, immediately you're going to get to the point where you're going to start making intelligent decisions about your education rather than just trusting other people to direct your education. I've learned over the years studying this whole, the academic system, that the worst thing you can possibly do, it doesn't matter if you're a young person or even an adult, if you want to get the best education possible, don't ever let somebody else direct your education. The students that perform the best, the students that get the best education are always students that take control of their own education, that direct their own education. The problem with the school system is that children are allowing other people to direct their education, and what ends up happening is they just waste 95% of their time. Because if you allow somebody else, and again, this is a lesson not just for children, it's a lesson for everybody. If you allow somebody else to direct your education, what ends up happening is what you learn ends up benefiting the person that's directing your education, not you. I know that may not sound like an important point, but that is probably one of the most important things that I could teach you, is that you need to direct your own education. And what that means is not that you can't learn from other people. You need to learn from other people. Most of what you learn is going to be learned from other people, reading books, going online, reading the newspaper, watching TV, attending classes. Most of what you learn, you're going to learn from other people. But when I say you should not allow other people to direct your education, what I mean by that is you should not allow other people to determine what you learn. Okay, you need to go out and figure out what you're going to be the best. You're going to be the most qualified person when it comes to figuring out what is best for you to learn. If you look at the school system, most of what you're learning is a complete waste of time. That's because somebody else is directing your education. You need to learn how to build a career, how to do something that you're actually passionate about, and how to make money doing that, and how to build a life for yourself. And that's something that's going to benefit you. But it doesn't necessarily benefit other people for you to figure out how to do that. So if you let other people direct your education, again, inevitably what you do is going to end up benefiting them rather than you. And so that's why you need to take control of your own education. So I could talk about that for hours, but basically go on this website and go down to the math, the high school or secondary education part. And you can see here there's the traditional pathway and there's also the integrated pathway. Please stay away from the integrated pathway. Integrated math has been proven again and again to be a very, very poor way to teach mathematics. I have students that I'm working with now that are attending schools that are using the integrated pathway, and the scores for these schools are very low. And that it's been known for a long time. The reports that I'm going to give you, the final report of the National Mathematics Advisory Panel, they mention it, that the integrated pathway historically has not worked. It's disorganized, and it's just we don't have time to go into that. But don't use that model. So you can see here we have Algebra 1, Geometry, and Algebra 2. Algebra 1 is the same thing as beginning algebra, so I'm going to click on that. And we have the introduction, and you can just read through this. And we have these are general ideas that they're going to cover, but then they go into a more detailed explanation of everything. And when you go through this list, you can kind of compare my curriculum to this curriculum. But I want you to understand that this curriculum is very different from my curriculum. And the reason is, what they're doing is they're taking a lot of kind of random mathematics and they're dumping it into the beginning algebra curriculum. And, we don't have time to go through all this, but for example, fraction powers. Fraction power, you see 5 to the 1/3 power. That is traditionally not covered in a beginning algebra course. That is traditionally covered in intermediate algebra. And so I don't believe that this should be taught in a beginning algebra course. And the primary reason is that it pushes all that other stuff. Again, look at this. This other stuff is the primary. You're going to spend the entire duration of the course just learning this stuff. If you try to throw fraction powers in there, then what it does is it takes all of this stuff and it kind of pushes it to the side. The math curricula in the United States have been described as a mile wide and an inch deep. And what that means is that they take way too much material and they just throw it in there. They just dump it in there. And students really don't master any of it. They just touch on each topic, so they're overwhelmed with material. It's completely disorganized, and that's one of the main problems with it. It's just disorganized. And that's especially true when it comes to the integrated curriculum. The material is disorganized, and students are just overwhelmed, and they don't end up mastering anything, and they certainly don't master really the most important thing to master, which is fluency in algebra, fluency in these algebraic topics. If you don't learn fluency in these topics, you failed. Okay, if you're a teacher and your kids went through your course and they didn't learn fluency in these topics that you see here, you failed. And if you're a student that's taking some course and you didn't learn fluency in all these topics here, you failed. It may not be your fault. And if you're a K-12 teacher who doesn't know these things, it may not be your fault. You may not be doing this on purpose, but these topics you see here, that's the purpose of a beginning algebra course. If students don't learn fluency in this, then they do not achieve the objective of this course. So that's the problem. The primary problem with this stuff is that if you throw this stuff that's typically covered in upper math courses into beginning algebra, it pushes the beginning algebra aside. What else do we have here? Again, we don't have time to go through every single one of these things, but there are things obviously on here that are very useful that we are going to cover. Inequalities and various relationships, systems of equations, solve equations. But here's a perfect example: is imaginary numbers. Imaginary numbers are typically not covered in a beginning algebra course. They're covered in an intermediate algebra course because imaginary numbers, that's a very advanced topic. The purpose of beginning algebra is to learn the basic algebra. It's supposed to be a first-year algebra course. I know that's kind of confusing because pre-algebra is mostly algebra, but because it's called pre-algebra, they call beginning algebra a first-year algebra course. And the purpose of a first-year algebra course is just to learn the basics of algebra. You may know how to deal with imaginary numbers, but if you don't know the basic fluency in algebra, it doesn't matter what you know about imaginary numbers. And so I'm not going to cover imaginary numbers. That's just is ridiculous. Why would you do that? The students don't have time to learn imaginary numbers. They need to focus on fluency in algebra. I'm not going to focus on conics, the circles, parabolas, all that type of stuff. Again, I don't recursive sequences. Why in the world would anybody cover recursive sequences and even function notation? Now, function notation oftentimes is covered in beginning algebra, but function notation is very, very, very confusing for students. I'm not going to put it in this course. I am going to teach it in my intermediate algebra course, but I'm not going to put it in this course because it's just something that is not necessary at this level. And so, but again, recursive sequences in general, why is that in here? I don't know why it's in here. It's just not something that's that important. And this, as you can see, this is very, very confusing. It uses function notation. So this is a perfect example of just dumping a bunch of random stuff into the curriculum. One of the big differences between a good teacher and a bad teacher is a good teacher knows what to focus on. Good teachers, they know. In my intermediate algebra course, for example, I'm going to spend at least a third of the course talking about quadratic equations and anything relating to quadratic expressions, because that is, the most important thing in the entire course. Whereas a teacher who doesn't really know what to focus on might only spend one day teaching that. I'll spend weeks teaching that, because that's a huge part of the calculus curriculum. If you've never taken calculus, you don't know. So, if you're a homeschooler and you have a liberal arts degree, or if you're a teacher who has a liberal arts degree, here's what I would tell you. You can teach math. You can teach the math curriculum. But when it comes to designing the curriculum itself, when it comes to determining what the curriculum should be, you're not qualified to do that. I'm not telling you this, to be mean or to be, to be harsh. I'm telling you this because it is true. You're not qualified to be determining what kids should be learning in the math curriculum. It doesn't matter how many you could have taught beginning algebra for 20 years. That doesn't mean that you're qualified. The purpose of beginning algebra, the purpose of all high school algebra and middle school algebra is to prepare you for calculus. If you've never taken calculus, you don't know what to focus on. Now, again, statistics and probability, that's another example of things that I'm just not going to put in this course. It's a general trend that people love to throw statistics and probability in just about every math course. And there are various reasons for this. A lot of people are going around saying that statistics is really the most useful form of math. I don't even disagree with that. It is probably one of the most useful forms of math, but the point of this school is to prepare you for college. You can know all the statistics and all the probability in the world, but if you're not fluent in algebra, you're not going to get through calculus. And if you don't get through calculus, you're not going to be an engineer. You're not going to be a scientist. You're not going to be able to major in biology, physics, chemistry, economics, geology. You're not going to be able to take any of those courses. So, you can make an argument that stats and probability is really important, and you will learn these things. I'm not saying that I'm not going to teach these things. I'm just not going to teach it in this course. The primary objective is fluency in algebra. Again, you can know everything there is to know about stats and probability, but if you're not fluent in algebra, you're not going forward in the curriculum. The algebra will stop you from even going forward. Stats and probability, it's not going to stop you. And that's why that list that I showed you it's the most important thing when it comes to your math education. So that's just generally what's going on is they're dumping a lot of stuff into the curriculum. So the point I want to make to you is that if you look at a curriculum and, a lot of these things, you see a lot of these things on this list, and then you compare that to my curriculum, and my curriculum doesn't have those things, you might say, well, I guess this guy's curriculum isn't very good because there's all this stuff that's missing. Well, that's not correct. There's, again, the curriculum is a mile wide and an inch deep, and students are not mastering the concept. So let's go over some of the things that I'm not going to cover. And again, if you're worried that I'm not covering these things, don't be worried, because I am going to cover all these things. I'm not saying that these things are not important. I'm just saying they're not supposed to be taught in a beginning algebra course, because if you throw this stuff into the beginning algebra course, it pushes all this stuff aside. But the problem is, like I said, I don't mean to sound like a broken record, but if you push all this stuff aside, you fail to achieve the objective of the course. This is the foundation of everything. So let's go over some of this stuff here. Inequalities, I'm going to cover in intermediate algebra. Absolute values, I'm going to cover in intermediate algebra. Equations with no solution or infinite solution, I'm going to cover in intermediate algebra. This is all stuff that I'm going to cover in intermediate algebra. It's very important, but I'm not going to cover it in this course. Geometry, these are all things that I've actually seen, and the reason that I'm coming up with this particular list is I've actually seen all of these things in beginning algebra textbooks. Traditionally, these things are not taught, but for some reason in the last 10, 20 years, they've thrown all this stuff into beginning algebra. And by the way, the idea that I'm doing something different from the school system shouldn't be that big of a surprise to you, because according to the final report of the National Mathematics Advisory Panel commissioned by the Secretary of Education, and if you don't know, the Secretary of Education is the highest ranking person in the public school system. According to that panel, commissioned by the Secretary of Education, they say, and this is their conclusion about math education in the United States, and people have known this for decades. It's not a big, it's not a mystery that kids are not learning math in school. In the United States, math scores are extremely low compared to other countries, and this is their conclusion. This panel, diverse in experience, expertise, and philosophy, agrees broadly that the delivery system in mathematics education, the system that translates mathematical knowledge into value and ability for the next generation, is broken. That's their conclusion. And, the things that I've been talking about are some of the primary reasons that kids are not learning math. The teachers that are teaching it are just not qualified to be teaching it. And, they're certainly not qualified to be determining what kids should be learning. So these are some things that you'll see in geometry and beginning algebra textbooks that should not be there. Sometimes they cover geometric principles. Again, these are very important things, but the problem is if you throw it into a beginning algebra course, you push the algebra out and you replace it with this. I've seen, some scientific principles taught. Scientific or significant figures, if you're a STEM major and you're looking at this, you understand how ridiculous it is to teach significant figures in a beginning algebra course. But I've actually seen this in a beginning algebra course. Why in the world would you be teaching that in a beginning algebra course? I mean, anybody who's ever taught a chemistry course knows this is a topic that causes a lot of problems. And it's just not that important to teach that. It's not important at all to teach that in a math course. The only reason that students would need this is if they're taking a science course, specifically chemistry. Chemistry is most often, those courses emphasize significant figures. And so you just don't need to teach that in beginning algebra. If you teach that, it's going to cause all kinds of problems. Significant figures is something that is not taught very well. The rules are not explained very well. And it's very difficult to understand what significant figures are. Even if you're focusing on significant figures for in a chemistry course, most students leave chemistry courses confused about what exactly it is. So because that's not really required for a beginning algebra course, why would you throw it in there, making things difficult for students and pushing all this stuff out, which again is the foundation of the curriculum. This is just one example of dumping random stuff into the beginning algebra curriculum and pushing all this stuff out to the point where students don't learn anything. Again, the curriculum has been described as a mile wide and an inch deep. So again, these are examples of scientific principles I've seen in beginning algebra courses, and these are just some things. I've even seen matrices in beginning algebra courses. Matrices are just not even necessary until you get more into intermediate algebra or pre-calculus. And when I was in school, I didn't even learn matrices at all until I took differential equations in linear algebra, the fourth calculus course that you'll take in college. So again, teachers, what they did is they said, okay, well, if we're not teaching enough math, let's just take a bunch of random stuff and dump it into this curriculum. And what ended up happening is, like I said, the curriculum became a mile wide and an inch deep, and it took this stuff. This stuff should be 90% of a beginning algebra curriculum, or 100% of it, and it turned this stuff into about 10 or 20% of the curriculum, and it guaranteed that students were not going to learn fluency in the math, so that it also guaranteed they wouldn't be ready for calculus. And that's what's happening with math curricula, with algebra courses. The point of an algebra course is to learn fluency in the algebraic topics that you need to go on to calculus. If you don't understand that, then you're not qualified to determine what kids should be learning in the algebra curriculum. And so I don't know if I can convince you completely that I'm correct. All I can say is this is the situation, and if you don't focus on these topics, and by the way, a lot of these topics are not necessarily that difficult. A lot of the stuff that they throw into a beginning algebra course is not necessarily that difficult. There's a lot of stuff that is thrown into beginning algebra courses that you can actually teach in a couple weeks. A lot of it is just not that important. Let me give you an example. When it comes to growth and decay, that's not really that difficult. You can teach that probably in a day or two if you really wanted to. And there's a lot of things on this list that really are not that difficult. For example, the Pythagorean theorem. That's going to be covered in my geometry course. It's not that difficult, but and so you can teach it very quickly. But when it comes to this stuff, you cannot teach this stuff quickly. This stuff doesn't take days, it doesn't take weeks, it doesn't take months. It takes years to learn this stuff. And so I'm not worried that students are going to learn all of that other stuff, really. But I am very concerned that whether or not they're going to learn this stuff. So again, the difference between a good teacher and a bad teacher is a good teacher knows what to focus on. That just gives you an idea of what's going on in the math curriculum and why I'm focusing on these topics. You need to be aware kind of of what's going on. But again, I hate to say this, but I have to tell you that if you've never taken calculus, you're just not going to understand these things. You're not going to, you're not going to understand why these particular topics are so important. Again, this is all about preparing you for calculus. And I just want to tell you that I'm not the only one that believes these things. Okay? There was a report, like I mentioned the report. It's called the Final Report of the National Mathematics Advisory Panel. And this is the link down here if you want to look at it. You don't have to look at this report because it may be kind of boring to people who don't really care, about this topic. But this report was released in 2008. It is a 12-year-old report, but everything that they say in there applies. And, you can look through that. I'm not going to go through it now, but that kind of confirms everything that I'm saying. I want you to know that people who understand how to prepare students for college-level math, they know this. This is not something that is a big mystery. And you need to understand that the way that people are teaching math in the school system, it's not working. So again, it shouldn't be a big surprise that I'm doing things differently. The report the commission says there are many gaps in the current understanding of how students learn algebra and the preparation that is needed before they enter algebra. I actually disagree with that. But they say what is known indicates that too many students in middle or high school algebra classes are woefully unprepared for learning even the basics of algebra. And so they're saying, look, kids are not, they're not learning algebra. Here's another quote from the panel. They say there seem to be two major differences between curricula in top performing countries and those in the U.S. in the number of mathematical concepts or topics presented at each grade level, and in the expectations for learning. U.S. curricula typically include many topics at each grade level, with each receiving relatively limited development, while top-performing countries present fewer topics at each grade level, but in greater depth. In addition, U.S. curricula generally review and extend at successive grade levels many, if not most, topics already presented at earlier grade levels, while top-performing countries are more likely to expect closure after exposure and development and refinement of a particular topic. These critical differences distinguish a spiral curriculum common in many subjects in U.S. curricula from one built on developing proficiency, a curriculum that expects proficiency in the topics that are presented before more complex or difficult topics are introduced. So what they're trying to say, they're touching on what I was mentioning earlier. They're trying to say that students are covering way too much material, and they're not covering it in enough depth. And they're not expected to master the material. The top performing countries like Singapore and Hong Kong, they're teaching math the way that I'm teaching math. That's an important point. The community colleges in the United States that teach remedial math, they don't teach it the way the high schools teach it. They would teach it the way I teach it. And the community college teachers, most of them that teach math, they have STEM degrees. Whereas the K-12 teachers, they don't have STEM degrees. Also, like I said, in the top-performing countries, they don't teach it the way we teach it in K-12 math schools, or K-12 math curriculum in the United States. They teach it this way, with my approach. So, also, they say teachers must know in detail and from a more advanced perspective the mathematical content they are responsible for teaching and the connections of that content to other important mathematics, both prior to and beyond the level they are assigned to teach. Again, these people are just all confirming what I'm saying regarding the math curriculum. They also say the effects of teachers on student achievement compound dramatically if students receive a series of effective or ineffective teachers. If I'm an effective teacher and you go through my math sequence, you're going to start to find out you're going to accelerate really, really fast. If you take my arithmetic course, my pre-algebra course, my beginning algebra course, and you start to take control of your education and you start to determine how fast you're going to move through those courses and you start completing course after course after course, you're going to start to go real fast through the curriculum. And that's not the way it works in the school system, because teachers have students for 9 months and those students are then taken away and given to another teacher. So even if you have a really good teacher in the school system, it doesn't really make that much of a difference as far as long term, because you're not going to be with that teacher for very long. Also, they say teachers of mathematics and science are significantly more likely to leave their teaching jobs because of job dissatisfaction than other teachers. And the reason for that is a lot of the teachers that have STEM degrees, they're looking at the way math is taught in the school system and they realize it's a joke. Kids are really just not able to effectively learn the math. And so again, these are just some things supporting what I was saying. Also, a lot of people try to prevent students from going forward. Don't let anybody try to prevent you from going forward in the math curriculum. If you have the prerequisites fulfilled, it doesn't matter how old you are, you need to excel as quickly as possible through the math curriculum. That is the number one thing that you can do to prepare for college and to perform better in school, is to go up the math sequence. And here's what they say. They start off by talking about gifted students. I don't believe in gifted students. There are only motivated students and unmotivated students. But they say there is no evidence in the research literature that gaps and holes in knowledge have occurred as a result of student acceleration. So don't let anybody fool you into thinking that somehow, keeping you back, slowing you down in the curriculum is somehow good for you. It's not. Okay, the only reason that teachers try to hold you back is because they're lazy and incompetent. That's the only reason that they're doing that. If your parents or your teachers are trying to prevent you from going forward, it's because of their laziness and their incompetence. You have to understand that the number one priority for parents is convenience. It's not your education. The number one priority for teachers is to make things easy for them and to pick up a paycheck. That's the primary reason that most teachers come to school, is to pick up a paycheck. They're not there, to ensure that you're getting a quality education. And we have 150 years of experience to know that the school system just does not work. So don't let somebody try to hold you back. If you want to get the best academic education, if you want to play the academic game and, be ready to go to Harvard and get a PhD at Harvard, you need to excel in mathematics. Don't let anybody try to hold you back. They say teachers and developers of instructional materials sometimes assume that students need to be a certain age to learn certain mathematical ideas. However, a major finding documented in a National Research Council synthesis of studies about science learning and reaffirmed in the Review of Learning Studies in Mathematics conducted by the Task Group on Learning Processes is, quote, "What is developmentally appropriate is not a simple function of age or grade, but rather is largely contingent on prior opportunities to learn." That's prerequisites. If you have the prerequisite fulfilled, you're ready to go on to the next level. If you don't have the prerequisite fulfilled, you're not ready to go on to the next level. It's that simple. They go on to say claims based on Piaget's highly influential theory and related theories of developmental appropriateness that children of particular ages cannot learn certain content because they are too young, not in the appropriate stage, or not ready, have consistently been shown to be wrong. Nor are claims justified that children cannot learn particular ideas because their brains are insufficiently developed, even if they possess the prerequisite knowledge for learning the ideas. So these people are, this is a report commissioned by the Secretary of Education. This is not just a bunch of random people, saying these things. So I'm not the only one that understands these things. If you're a STEM major, if you earned a STEM major in college, and you're listening to this, you're just nodding your head. You're saying, yep, everything that he's saying is correct. I mean, STEM majors, they all know this. But you have to understand the STEM majors are not teaching math in K-12 schools in the United States. Okay, liberal arts teachers are teaching math in the United States. Very, very few people there's a book. I'll give you I'll show a page of the book where it talks about how 95% of the teachers in the K-12 schools do not have STEM degrees. If you took 100 K-12 math teachers, I'd be shocked if 10 of them had STEM degrees. The people that are teaching K-12 mathematics in the United States, they just are not qualified to determine what kids should be learning. But despite that, they're designing the curricula. So that gives you an idea of what's happening with the math curriculum in the United States and why I choose to teach these things. And again, even if you disagree with me, even if you say, well, I want to rest on the side of caution and I want my kid to learn these things too, fine. Your kid is going to learn these things. If you're a student, you are going to learn these things. I'm not saying you shouldn't learn this stuff. I'm just saying that you're going to learn it in other courses. This stuff is the focus for this course. If you don't learn this stuff in any beginning algebra course, then you fail to achieve the objective of the course. So that is my explanation of the course content. And by the way, these principles are true for pre-algebra. They're true for middle school mathematics. They're true for 11th grade mathematics, intermediate algebra. All the courses are pretty much the same trend is occurring. The curricula are a mile wide and an inch deep. Kids are a lot of stuff is being dumped in, but they're not learning mastery of the basic algebraic concepts, and that's the point of these courses, is to learn fluency in algebra. So that's my explanation in terms of my course content. And my advice to you is, if you want to figure out what should be taught, just ask a STEM major. Just ask them to look at this. They're probably more qualified to say what should be taught than the K-12 teachers in the school system. But that was class 1 of my beginning algebra course. And so now I want to talk about the homework. The homework is very simple. You need to get this equipment. Remember, we talked about how to stay organized. If you're going to choose the 3-ring binder route, you need to go to the store and get all this stuff. That's your homework for today. Notice that I didn't cover any math today, and you don't have any kind of math assignment. The only assignment is get this equipment. And if you choose to go the digital notebook route, get your digital notebook. And so get that equipment. That's your homework. Be sure to do that homework. Get that equipment before you go on to the next class. And I'll look forward to seeing you in the next class.